Okay, cool. Today I will be talking about how to refactor and upgrade the mobile app. My name is Boskin Kostiantyn or Kostiantyn Boskin. So you can call me Konstantin if that's easier for you guys. I'm CloudFlex co-founder and software engineer, mostly focused on the mobile. That's was my biggest focus during my career building. Now I'm founding a company. Today I'll be sharing my experience with regards to refactoring process. We'll be talking about what it is, how it can impact real business of the customer who runs mobile app, and how it can impact speed of development of the mobile app itself. At the end, there will be a section for questions, and I hope I will provide extended answers and will answer all your questions. So I hope you will enjoy and will use my experience in future because it's pretty common request from the customers based on my experience that the app doesn't work or something is going on in the wrong manner. These are things refactoring is aimed to solve actually. So let's get started. What is refactoring itself? That's actually a good question. So before we are getting too deep into details, let's spend some time just trying to figure out with terminology. Refactoring itself, it is a process of existing code restructuring without changes in external software functionality or behavior. That means features has been developed, let's say authentication, they behave in the same manner, but code which runs this feature, it has been changed in some better way. So the goal of refactoring is to enhance the design structure or the implementation of the program, keeping the software functionality as is. What does it mean? Let's say you have an old code and you would like that code to be upgraded. Let's say this code is just using some old libraries or old dependencies you don't like. That shouldn't impact how the functionality works itself, but you would like to change the code. So that's what refactoring is solving actually. It changes code without functional changes. The definition really might sound complex a little bit, especially for people who are not familiar with engineering aspects or who have not coded intensively during their career, but it's pretty easy to explain in real life examples. That's what I'll be doing. Yeah. Though modern software is a really complex and it's absolutely separate area of application, probably we can compare pretty straightforwardly software product with the machine. And machine is powered by engine. So the better engine is, logically, the smoother you ride and less chance for break in the middle. As you can see on the image, engine on the left is really dirty. So it has some like metal corruptions on there. It also looks like it just hasn't been maintained for a while. So what it means? That means that, for example, the hose can fall off, or it's just not easy enough for the engine itself to pump gasoline, which can impact speed of car or other like when you're just trying to turn left or right. So that can just impact how you ride. So refactoring is aimed to maintain machine's engine state when it's on a ride and improve characteristics of the product itself by making internal changes. What does it mean? On the right, you can see engine, which actually engine after overhaul or refactoring or um, other change made internally. So when you make this change to the engine, you don't change the look of the car itself, right? And the car still rides. You can still turn or turn off the lights, turn on or turn off the lights, and you can still make your rides at the end of the day. But the engine looks way better now. So that's what refactoring does actually. Um, the difference is comparing to the real world that in real world you cannot add another section to your car, but in software you can, and that's why it's beautiful. So it's important to keep all these things clear and clean to extend in future with reasonable efforts because um, when you want to create another feature in your mobile app, it might be just pretty hard to figure out with legacy stuff because as you can see on the left side, there are some weird wires. It's not really clear how they work. So you just might break something by accident because you don't know how it's operating on the internal level. So I hope that makes sense. Um, So moving forward, there are two parties who may want this actually. So first party is engineering team, and the second party is business owner. Um, Based on my experience, initiative comes from the engineering team mostly, but business doesn't understand value of these actions because they might sound like resources spending without any improvements, and and users might see so, like what's the benefit of changing this engine if it rides and it seems like it rides smoothly. So um, that's not really true, and there is an impact for the end users when refactoring is made, and they might have a huge benefit from that actually. So um, the moving forward, I will explain how they can benefit and customers from that. So I would like to start with motivation engineering team might present for applying this procedure to the software, and why they would like to spend, let's say, a sprint or maybe a half for making those changes. So why engineers would like to refactor? So first, engineers usually complain for software code structure or some legacy, which might be confusing and hard to support. And that's really true because people are different, people are unique, and everybody writes a little bit different code. And if it's not standardized, it's pretty hard to figure out with that. So reasonable question is, what is legacy? Legacy code is a code which has been written by someone else, and it's really hard to maintain or extend it. And yeah, it sometimes might just read like Elvish, and you're really reading through the code and don't understand what's going on here and how it can, uh, how does the code affect the end software or interact with the product. So second reason, based on my experience, is all technologies in a project. The thing is, modern engineers achieve efficiency by using modern tools. There are libraries which are making life easier. There are frameworks which are dedicated to simplify development process and take off some headaches. So that's reasonable that most of the developers want to work with new approaches, which usually just more simple and elegant. And nobody wants to work on a diskettes as it was in like zeros or something like that. And suddenly, what I've noticed is it is constant pressure from the customer while developing more features. New development always adds additional complexity, and the more code in the software, the harder it's to maintain that. At some point, it's just really hard to figure out with what's going on in the program, and engineering team can request to dedicate maybe a sprint, improving critical parts, writing some automated tests, and making some other checks. Um, so yeah, these are main factors I have found for myself during my career. Now let's chat about a little bit what's going on from the business standpoint. How does it work, and etc. So there are a few indicators noticed um, which may um, may give a thought to business that it's really a time to dedicate just some development time to improve software internally. So here are these markers. So first marker I've noticed is new features development takes really more time in general than usually. What does it mean? At some point of view, feature development, let's say it's I don't know, another list view, took X time. But now when you want to add actually the same list view in some other part of the program, so let's say it was on a hero page, and now this list view would be presented somewhere in the profile, let's say bookmarks of the items user has chosen for himself, it takes X times two. So it sounds like it shouldn't be taking so much time. And that's reasonable actually. So it shouldn't be taking so much time. But the thing is, there might be internal dependencies software engineers aware about, and they cannot just present it, but they know that they affect and estimate. So that's why that's the first marker business should consume to consider if they should make a refactoring. Second one, there is actually suddenly a lot of critical bugs after each development iteration. What does it mean? So when your feature is developed on the QA stage, draw like let's say 5, 10 crashes found during development. So that shouldn't be working like that. If that's uh, uh, if that's the reality, that means that code is not really well organized because code actually produces bugs, um, and code is written by engineers, so probably there is a huge opportunity to optimize internal code to avoid bug fixes, and that could save a lot of time on the regressions and QA process. Third one, engineers are not adding unit tests, or it's pretty hard to add them, and they're saying that directly. So uh, the thing is, unit tests they are at the lowest level of testing before any other stages of testing, and oftenly I'm found in software which doesn't contain any unit test, and that's a pity, unfortunately. Um, so it's important to keep components separated enough so that team can write unit tests to check single function or a piece of code. Unit tests are usually not added, not because software engineers are lazy, but just because it's really hard to add them. To avoid that, software should be just designed in a way to comply with solid principles and other principles like dry and kiss. We'll be talking about them later, so that it's always uh, at any stage of the life cycle of software, it's easy to add unit tests actually. So that's a factor for considering refactoring as well. Um, Fourth, it's challenging to extend existing functionality with new features. And yeah, that's something I have been talking about just a few minutes ago. When same functionality in some other place takes unreasonably higher amount of time than it should be taken actually. So yeah, that also produced by probably internal source code dependency and etc. Though there are features which might be just complex. That's true. And fifth reason is time factor. After some time in production, the just parts should be revisited just because there is functionality developed urgently, etc. So there is always a little amount of tech debt engineers are aware of. So they should just dedicate some time after 3 or 4 releases to figure out with this tech debt to maintain software in good shape. Moving forward, how much time can it take? So this is pretty hard question to answer, but I will try. So to answer that, let's just figure out first with factors can impact this time, because there are multiple factors impacting on this topic, and each situation is unique. So always depends on the product complexity itself, team seniority, software state, and pressure created by urgent product development requests. These are three main things I'm highlighting. In perfect world, tech dev fix should happen each probably 2 or 3 iterations of product development, means 2 3 standard sprints if you're working through the agile, or if it's a Kanban, just consider to dedicate another week spending to fix tech debt found in the product. Uh, why it's only 2 or 3 sprints, or like even a week, just because there is no huge code pieces which should be written and knowledge about feature is still fresh. So I mean, when software release is happening, let's say software release has been achieved by 2 week sprint, and there were a few software releases recently. Let's say 2 or 3 versions have been spin-off. What does it mean? It's better to allocate a week of time trying to solve tech debt, which has been collected during this development, rather than once per year making a huge refactoring and adding a lot of bugs actually to your software. So the thing is, if you do that regularly, software the changes to the software they are clean. The memory and knowledge about features of the team is pretty clean as for now, and they remember all the requirements, so it would be just easier to pass QA stage and add unit tests. So it just adds a lot more transparency. Of course, impacting thing is pressure by new features requested. What does it mean? It means that if there are urgent development, it can also impact how much time does it take to refactor the stuff, because urgent development should always be priority. Okay, so these are impacting factors, but what about average time? Uh, so on average, in the reality, unfortunately, refactoring can mean massive changes and happens not so frequently as it should. and if software is in bad condition and doesn't follow solid principles, which are base principles good products should always follow, it's worse to plan at least 2 or 4 iterations and spend half of a first analyzing issues and prioritizing them, as well as mapping dependencies. So yeah, really one sprint. And start development work only after doing this, keeping in mind that it's better to over communicate than bug fix, because it's better always to spend more time collecting something than just making bug fixes on production or hot fixes for a huge customer base. That's just awful. So yeah, that's real case example, I would say. Reasonable, if that takes so long, how can product even benefit from that? So a few action items here. There is definitely an improvement in software maintainability and reduction in support costs for future. There will be just less bugs. For existing ones, it would be easier to fix them. That means when product is stable, released, and already in production with some user base, it's easier to sleep because there are no urgent bug fixes or hot fixes on production. And that means just product paying less money for developers to fix bugs, and it can spend more time developing new cool features. Second one is definitely improvement in software extensibility, because software, if it's well designed and has minimal amount of tech debt, is flexible to changes. Feature requests are less painful, and it's just easier to apply changes as product grows. Third one is potential boost in performance and glitch fixes. There might be just some like random glitches over the product no one wants to fix, and during overhauling, it's probably developers can find the root cause for them and handle them gracefully, so that it's not an issue for the product. And there are also implicit benefits like happiness of engineering team and no fingers crossed releases. That's important, I guess, because it's super hard to maintain something which has hundreds of thousands of users without unit tests. I mean, that's really hard. Yeah. So moving forward, how to ensure that features are not broken if this procedure has been applied. I spent a little bit of time thinking on that, and the decision was to create this diagram, and I will explain how to use that. So green lines are identifying best case, and this diagram, just a disclaimer, it's super easy. I mean, there is a lot more conditions in that, but just for simplicity, I've added um, most happen these ones which happen most of the time for me. So green ones are best case. So if something is already present and you don't have to spend some time collecting that, and etc. And in general, this diagram would be something which is actually recursive. You'll figure out moving forward. And red ones are identifying worst case, means you have to apply another operation if that happened. So now let's try to move with green lines and see how the best case works. So let's say you are starting in init refactoring, and before making any changes, just make an operation to make sure that there is enough knowledge about functionality you're going to work on. And ask yourself if there are unit tests. If yes, that's really perfect. It's easy to verify if code changes are working in intended way, and you go straightly to the spend more time making exploratory testing, means just manual verification and another retest on QA and deploy. The thing is why this particular pass is so easy, because if there are unit tests, probably the software is segregated enough by component, and each component is responsible for functionality. Otherwise, it would be just hard to add unit tests. Though there are products which have unit tests, but they are not following this rule. um, let's now try to go to the no pass if there are no unit tests. So what we should do first as developers, we should ask your department for test documentation. Probably there is one. Um, is documentation available? If that's available, that's cool. So we should read that, mark down requirements, and after refactoring, make sure to run dev test before passing over QA. Then spend some more time making exploratory tests and trying to find some hidden features, or maybe even just do white box verification as a developer, and then send to retest after changes and deploy. If we go to no documentation available, which is right to the right of yellow romp in the center of diagram, we should go and find product owners and ask them for requirements and document them. So that would serve as a source of truth for us, and we will be actually making some feature development based on requirements, but not based on our just feelings and past experience of how that should work, because that might be not what product wants us from that feature. And then always spend some time making exploratory testing and retest after changes. So always retest, just do a fair amount of testing. That should be um, how that should be the factor which keeps software from breaking, and it will just make it safer a lot more. Okay, so now when we have discussed that, there is a little summary intermediate, like generic refactoring strategy, which would be technology agnostic. Actually, it's applicable for both backends, mobile development, other stuff. So first thing we need to do, we need to identify that it is time to make an upgrade because of the factors we have discussed in previous slides. Probably the engineering request or other markers we have noticed. So second stuff is get rid of urgent pressing factors like features to keep focus on refactoring. What does it mean if there are development which is pressing on software engineering team? It's better just to postpone refactoring and finish development before figuring out with other changes. Third, make analysis of present issues and collect update. Spend from half of a sprint to one dedicated sprint. Then make planning, develop, test, release, and get a profit from that. So that's pretty simple. Just get rid of pressing factors, analyze, and then develop, and then retest. Always retest. Uh, okay, let's move forward. Um, Next couple of slides will be more technology dedicated, so there is no generic terms like try to analyze, spend some time, and etc. So we'll be diving more in the mobile specifics, and we'll try to figure out with a native app what should be applied. So mobile apps have wide range of technologies they can be developed with. That's the thing. It can be a native app. It can be written in Kotlin or old Java or maybe old Objective-C or Swift, or it can be a cross-platform app like Flutter or React Native, or it can be something hybrid. So there is plenty of variants. And depending on technology, there are different ways to refactor actually. So um, also something we should consider while doing refactoring is heavy backend dependency. That's really specific to a mobile or just to the front end, I would say, because it's possible to find that apps are slow because API is not designed to serve client app and needs to be restructured on the API needs to be restructured. I mean, for example, you're making 3 or 4 requests instead of making one, and they are just slow because you need to make on the session level all these handshakes. You need to wait for the responses and etc. So there is optimization might be found in just some other place, but that will be just that will be found during code inspection. So where should we start from on a mobile? Uh, Start with just verifying that you are aligned with solid, dry, or KISS principles application in the app. It would be base and give software enough flexibility, but would keep it resistant to bugs. So reminding that solid is single responsibility when each component is responsible for only what that component should be responsible for. Like, I mean, your notification manager class, let's say, doesn't make any I don't know UI presentation except of notifications, so it doesn't control UI of your app. That's weird. Open closed means it's easy to extend functionality, but it's hard to change internal already existing functionality. uh, Least of substitution is when you can just easily substitute some classes with implementation based on their interface. Let's say you would like to migrate from unsecured storage to secured storage. So if your storage itself is under the interface, that means it would be really easy to do that because you just create class which implements this interface and substitute that somewhere in a DI container or whatever place. And dependency inversion, yeah, like low level modules, they top level modules, they should never be dependent on low level modules. I mean, animal is base class for all animals, and animal should not be checking somewhere internally of itself if dog, if cat, if giraffe, for example. So that really makes hard to maintain functionality. Second principle is dry. Don't repeat yourself. These are just famous principles. Just don't make any copy paste to the code. Better move them to a separate class and involve function from that class than make a copy paste of yourself. And keep it simple. Simple. There is another word, but I would probably omit that. So try not to overcomplicate things if there is no need to overcomplicate. In Python, there is a beautiful convention telling that implicit worse than explicit, and like hard is worse than simple. So it sounds really simple. You should just do things which would be easy to develop, the easy to read, easy to maintain, and combine them to achieve like complex functionalities. So yeah, and don't make non-transparent changes. So moving forward, I would like to discuss a little bit solid application, solid principles application, architecture, and tech stack itself for the mobile app. So these principles they can be gracefully covered by really modern tech stack. And Android example would be, for example, we are using Dagger or Hilt or Coin for dependency injection, and it also has some sub-dependencies as a result. So it would also keep code flexible enough. It would help to achieve interface segregation when you write binds function or provides in your Dagger container. It would also keep modules independent enough because you would structure probably your dependencies by feature, and that would already make software aligned with these principles. I mean, it's already it already has list scope substitution, it already has interface segregation, it probably has single responsibility, so there is less you should maintain on the code level by that moment. um, so just advising to keep classes responsible only for their functionalities, that's really important, and design assuming there will be other related features. That's why I need to create interfaces, and it would be easier to maintain those features. um, So architecture, modern architecture, probably best one I have used ever was Clean. It's a little bit big, but it's designed for any case can happen in your life. So just create entities, create use cases, then create presenters and create UI, and make data domain and presentation layers. On data layer, just put everything which works with data. Let's say API calls, some storages on the domain. Put your repositories, which would be responsible for chaining calls from your data sources, so that you can already easily replace data sources with some other data sources, right? Because they are segregated and separated in some other classes. Then just combine your repository calls in some use cases, or if you feel that's redundant, for presentation layer, use whatever you want. Call them directly from the view model with coroutines or whatever you want actually. So it doesn't matter. At this point, your app is so flexible that it can apply any technology change you want. If you want here to be RxJava, just do it with RxJava. If you would like that to be with Kotlin coroutines, do it with Kotlin coroutines. If that's something older, it's not an issue at all as well, because classes are separated, segregated, and you can manipulate them easily, replace, change, or do whatever you need. And you can cover them with unit tests, of course. And unit tests would be transparent enough. Um, so if you find that your app is good on the conceptual level, what should be your next action? So that's good. That's good news. Just here are a few next steps I can tell you. So make sure app uses official dependencies which Apache compliant or GNU compliant. If there are other third parties, fork them to organization at least and use from that repository. What does it mean? So the dependencies in your app, they can be some third-party libraries, for example, developed by single engineer, and they not maintain that. That creates some risk of break, and also with regards to compliance, that might create some risk of having a wrong license for your software if you distribute that for commercial purpose. So just make sure that dependencies are good, they are maintained from organizational repository, so that you can always go and make change to that repository in your organization and fix bug if that's found, and yeah, always do the job, better job for your product. So Look through the code and see if parts can be moved to configuration files. ID shouldn't be hard coded, etc. That might sound simple, but that would also reduce a chance of security break. Because, for example, if there are some IDs hard coded in the app, that means probably if this app is not obfuscated, attackers can just read through the code and find those IDs and use them in some way. For example, put in the backend request or something like that, secret code. So make sure that all configurational stuff is moved to configurational files. That might also be a bigger effort because hard configuration they might live in such places that it's just not easy to change them. So yeah, just make sure configurations are in configuration files like Gradle, Pleased, and etc. Um, add unit tests, fix to-dos. There might be there is just huge space for optimization there. There is always lack of unit tests. There is always hundreds of to-dos. Let's say something has been found during ticket X, and now it can be fixed finally. So yeah, that's the thing. Just make sure they are all fixed. Profile for memory leaks with leak canary and remove if present. That would just make your app more smooth, and probably you will drop some pieces of code which are not easy to maintain because it happens that pieces of code which are not easy to maintain are causing memory leaks actually. And yeah, profile using Android Studio Profiler to see where app can perform better. You may find there are a lot of interesting options from layout inspections to database inspection. So there is definitely more space to optimize if we go too deep in this technical stuff. Okay, so answering main questions, how not to break while refactoring your app. There is no perfect path which would work for everyone. That's true, but we recommended next steps on top of recommended before. And what I mean by recommended before, I mean generic strategy applicable for any technology. So first, map critical features important for business. Write unit tests for them first if needed. If not possible, just mark down requirements for them. Apply refactoring changes, retest both on dev and QA side, and deploy to production. So that should be pretty much it, actually, to achieve solid understanding that your product works perfectly well and there is no additional bugs than uh, there has been before because there are always bugs in the software. Um, Here are some results I would like to share based on one of the projects I have completed recently. So after refactoring, we have noticed bug reduction around 20%, and it was around 20% faster for developers to develop. So we did manage to take into the sprint more tickets because first, development team is familiar with the functionality. Second, there is no legacy code. You should spend time trying to understand what it's for. And yeah, these are main factors. And bug reduction was just gracefully handled by dropping some odd code. And second one is memory leaks decrease 3 times. That's also by making some changes and applying new technologies in modern software requires actually. We have collected a lot of additional documentation and created test suites, created some Confluence pages explaining how this or that works, documented analytics events, and etc. And we have added around 500 unit tests, which made QA more confident about releases. So I think that's a big win because there was a situation that there is only one QA on the project. So there is a lot of functionalities, big platform, and it's really hard to test. So now, if people can sleep better, that means we have achieved the result. Um, so yeah, probably from the presentational standpoint, that's pretty much it I wanted to share with you today. So I really thank you for the attention, and I'm ready to switch to open questions if there are some. If you have open questions, just post them in the chat. I will try to answer them. while you are thinking on the questions, if there will be any, I would like to share one of the experiences we had, how we solved an issue with the app with some um, like not really refactoring, but some interesting steps. So there was an issue that the app was hard to maintain, and it was really challenging to extend it with new functionalities. So when we have found ourselves in this situation, what we did an investigation, of course, and we. Oh, sorry. Yeah, I've noticed there is a question. Ilya, you underlined, reading the question, you underlined importance of unit tests several times. How important would you say are other types of testing, integration tests or contract testing? So um, this testing, since the presentation itself designed mostly for the product owners and developers, I skipped importance of these steps, but based on the diagram I have presented here, let's get back to that quickly. Based on this diagram, as you can see, all the steps, they are leading to spend some more time making exploratory testing. That's for the developer, and retest after changes. That's for the QA. So with that being said, steps you're mentioning, um, integration tests, contract testing, like when you try to uh, make sure that parts are working correctly together. These are the most important, crucial parts, which would confirm or deny that you have made changes um, correctly. Because only during QA test, since QA wasn't developing that, it will appear if changes are working correctly or not, because they don't have blurred eyes on the functionality. Dev test is always worse than QA test, just because developer has been developing that, and there is already focus on some happy paths, but the person doesn't think about some additional cases which might happen. Uh, can I copy the diagram? Sure, go ahead and copy that. I don't mind. You're always welcome. Um, Switching back, so while there are more questions to come, what percentage of testing is worth having unit regression tests? So I would say play it on the safe side. Unit tests should cover at least 70% of the app. Uh, how many tests would be there on the QA side? That depends on QA department, of course, but I think if there is at least 10 or 15 tests per each functionality, if that has some add-ons in the functionality, like you can change profile for this role or for that role, it was creating at least 10 or 15 test cases in test documentation for the QA. But for unit tests, I would say at least 70% to play safe side. If that's less, probably you're not well covered, or you have just a lot of classes which should be excluded from the test run. Like let's say with unit tests, you should test your functionality, but not framework itself, right? So there might be just classes which are impacting overall test coverage, but they don't have any value because you're using them from library. What about cases written by QA? You mean auto tests? In comparison to unit tests. So I would say if you're asking if that should be more unit tests than tests created by QA department, there should be definitely more unit tests, because unit tests is testing smaller piece of code, and QA department should probably focus on integrational sync, or just how the components interacting together, because that's something developer can test worse because he knows how they can interact, and probably there is less chance that he will be doing something except of happy pass. So yeah, more unit tests. Yep, you're welcome. Okay, don't hesitate to reach out with questions. We still have some time. Okay, cool. So while we have 3 minutes left, I wanted to tell you additionally about some experience how we refactored without refactoring. So as I started telling, there was an app which was hard to support because it was just lack of resources in the team for our customer. So how we did that, instead of doing applying massive refactoring change, we have just made everything until bullet number 3. Here, I guess it's bullet number 3. So until apply refactoring changes, and we just mapped critical features, written out unit tests for the old app to be sure that that behaves correctly, and then mark down requirements based on these unit tests as well, partially. And then we have just rewritten that in Flutter. So that worked perfectly well for us. So also use this technique. Don't be shy to refactor in modern technologies that work perfectly well. And I encourage every engineer and every product owner to use new modern technologies, new approaches, because it would make life simpler and product more robust. Thank you so much for the attention. If there are any other questions, here are my contacts. So please reach me out anytime. I will do my best to answer them. Thank you so much and have a great day.